Um, how many of y'all have done some project in your undergrad and what project it is about? You can unmute and speak about your project in general. Hello?
Or IoT based attendance system.
Okay. So just tell me what is the front end, back end, and what that project does.
So front end was on React and
Okay.
back end was on PHP Laravel.
Hmm. Any
And
database?
uh, actually, sir, back end was handled by my teammate.
Okay.
So
But there is some database, right?
yes,
Okay. So how many people did that project?
we are four.
Four
We were
people.
four. Yes,
So one person took care of backend, one person took care of web layer, the other person took care of the integration, right?
yes, sir.
Okay. Any other students wanna just share their project? I'm trying to connect this your real world project with the session we're gonna do today. Okay. Anyone else? So do I need to assume that none of you have done anything in your undergrad as part of some project? Okay. We'll go with Ashish's example. So when four people were building this project, how did you present that to the presenters, Ashish? Did you use in one machine or did you use a shared machine? How did you deploy and share it with, present it to people?
Sir, we were using application on different phones and laptop as a host. So it
Hmm.
was using Bluetooth as a communication between laptop and phones.
Laptop
So
and
to take the attendance,
oh,
all
laptop.
devices.
Yeah, laptop and mobile phone, right?
Yes, sir.
Okay, cool. If you want someone else to use your product, how do you ask them to deploy? Just asking, there's no right or wrong answer.
So we have to deploy on some cloud platform.
Then,
Then we have to map it with some domain name,
hmm.
and that containerization concept also comes in that.
Okay. So the agenda of today's session is containers, and we'll tell why it is important. So we'll take your example, which is your project. Okay. So imagine Ashish team. So there are four people. Person one was looking at a DB, let's assume. Person two is looking at the web. Person three might be looking at integration. Person four might be looking at test cases, deployment, etc. Let's assume this is the case. Okay. So they have a DB. Let's assume the DB is on Postgres. Okay, some version x.y version. And when they have web, they use the React. Okay, this is their web framework. And backend they need Node.js, npm package, hmm, all other JS packages which they have. Okay, they need Vue.js or Express to launch. Then for integration, yeah, you need these three for integration typically with the DB. And then to test and deploy, you might use some unit testing. Okay, and you run some batch scripts to deploy. Okay, this is the tech stack you need. So because it is just a undergrad project, four people manage to use their own machines partially for their internal development, and eventually they'll rely on one common machine to integrate and present to the presenters, right? That's how typically the undergrads do. If you extrapolate this problem to an industry where you have different teams who take care of database, who take care of the web part, who take care of the integration, and imagine there are 100 people here, 200 people here, 500 people here working on different items. They can't mimic the approach which Ashish's team has taken. They can't work on one machine and do the presentation. They need a common playground so that the DB people who are working in DB come and dump something here. DB people working on web can come and dump something here. People working on integration can come dump here. And there should be a mechanism where the common playground should be able to become a presentable presentation layer, okay, for people to consume. Now, traditionally, everybody who used to run IT companies take the approach which Ashish team has taken. Okay, what is the approach? If there are 10 developers, for every developer they used to give a machine. They used to ask them write a code, then they'll collect the code, dump it in one machine, and they deploy. Okay, but now when we have version control, Git, and all those tools, remote development and merging and to one remote repository and pulling that to one common machine to deploy was also becoming has also become easy. Okay, but what has become a challenge is if new users started coming into the team, they have to set up their machines which all the tech stack which is available for the entire product to run should be sitting on each and everyone's machine. Okay, so if there are 1,000 employees, they have to buy 1,000 machines, 1,000 licenses for Postgres DB, 1,000 licenses for Node, NPM, Vue.js, all supporting tools. They have to buy all these licenses and have it individually deployed and come up with a presentation layer like how Ashish team was trying to present to the end users. Okay. Now this is a costly approach, not scalable, because if someone is using React, let's assume X.1 version, another developer figured out that there is a X.7 version where an inbuilt function exists which I don't need to write 10 lines. They're just giving one line for me to implement. Because with this version mismatch, there could be a build failures because one guy is in old React, the other guy is in the new React. Similarly, a person who is working on one version of DB might be using x.y, the other person might be using x.y.1. This mismatch will eventually lead to the blockers. So in those days, whoever is the CTO or whoever is the VP of engineering used to define some guidelines, okay, for generating builds or for building the releasable prod code artifacts. Okay, for releasable prod code artifacts, they have to pass certain guidelines. What are they? All the dependent software should be in fixed version. Okay, all the machines should be in a same dev mode. There shouldn't be any other additional tool. Okay, and all the connections which are set up by these machines should be similar. What are those connections? Typically environment variables. Are you all aware of environment variables? Just say yes or no.
Yes, sir.
Okay, good. So the environment variables, they have to be fixated. And if you are using any local code, you should not use the local code and push that code into the respective build uh, without passing the code review. So they will define these guidelines so that everybody abide by the guidelines, and it is observed that people who followed these approaches, uh, had delays in product deliveries, primarily because some guy randomly installed something. When I was working in 2012, there is something called Notepad plus plus, okay, which is like a text editor. One of my senior, everybody in the company used to use IntelliJ, okay, in those days, IntelliJ, or typically Vim all the time to write our. One developer used to write code in Notepad plus plus, and he used to manually bring in the dependencies by declaring them in the code. But Vim used to automatically take care, in IntelliJ used to automatically take care. So when his code went into the production without a code review, because he was the code review guy, the build got fit, primarily because it didn't pick up the right dependencies. There was a version issue, there is a compatibility issue. The build which got generated, the guy who is generating the build has skipped the version conflicts, and eventually when it went to production, there were some minor issues where people are unable to comprehend why is the problem. So there were such real world problems which all the engineering teams have uh, um, had to go through. And if you look at this model of managing the code, if tomorrow my company hires another 10,000 people and if my headcount is 11,000, I have to eventually buy 11,000 machines to have a common tech stack to do the development. Okay. To avoid this problem, there is a better approach was introduced that is called virtualization. Okay. What is virtualization? Imagine you have one machine which has an operating system. Operating system has a kernel. On top of kernel, you have system utility programs. On top of that, you will have your applications. Okay. So your Microsoft Office, your IntelliJ, and your Python sit here. Utilities, calendar, date timestamp, task manager, performance management, folder management, device management, memory management sit here. Kernel will do all the input output operations, disk operations, preemptive scheduling, all those stuff. And operating system will has the internal logic to manage all this show. Let's assume this is a typical hardware machine, and you will have a ROM and a RAM to support stored data and on-demand data management, on-demand access management. So imagine a machine has all these aspects. What virtualization software does is they can typically create a copy from one instance of the machine and mimic at a at a hardware level, at a OS level, at a kernel level, at a system utility level, and at an application level. Okay, how it does this activity is, the first concept you need to understand is hypervision. Okay, hypervisor, some people call it as hypervisor. Hypervisor tells you that when I pick a machine, a hardware machine, imagine if it has Pentium 5, uh, and then hardware hard disk of 10 TB ROM and 1 TB of RAM, and if I have Linux and a kernel and a utility program, I can use hypervision to break this into small chunks of operating systems. Okay, so I can divide this 1 TB worth of ROM into 2 TB, 2 TB, 2 TB. Okay, then I can divide this 1 TB of RAM into 512, 512, 512, and I can break this OS and create a clone. I can have its own kernel. then system utility programs, okay, then apps. So products like VMware, okay. I think if you're in BTech, if you have tried, I think you might have tried Oracle VirtualBox. At least I tried it. It's a very simple tool. These are very famous tools. There's other tool called KVM, which I think most of the people in industry use. It's called kernel-based VMs. Okay. What this software does is you have to supply the hardware, operating system, kernel, utility, and app. It will create copies of instances of that machine, and we can call them as virtual machines. Okay. So your physical machine has this much of, this is a configuration in RAM, ROM, and chipset. Your virtual machine will have piece of that chipset, piece of that hardware and and software. So virtualization actually help you to buy the existing, use the existing hardware and create small copies of virtual machines, so that you no longer need to buy physical machines to all these people with all the tech stack, which is license intensive. You buy one full length rack. Okay. How does the racks look like? I'll show you. So these are typical data center racks. Okay. All you see over here are the CPUs, and they will have RAM and ROM. What typical companies does is they'll buy one full rack, which is like 5000 TB of ROM, uh, 500 TB of RAM, and an operating system will be installed in it. It has a shared kernel and a utility program. They'll deploy VMware on the track. Okay. And they will start creating clones, virtual machines out of that rack. Okay. Now this way they solve one problem. What is that problem? You don't need to eventually buy too many machines, too many licenses, and ensure that you buy once and create as many VMs as possible. The primary advantage with this approach is, if there's an issue with the machine, you will kill that machine. But if you have an issue with a virtual machine, you can kill it. This amount of 2 dB 512 will go back to the actual size of the hardware, and you can create another VM with the same configuration. So you are scaling your environments vertically by creating pieces of virtual machines from the hardware you bought, so that you will get individual machines for different people to work on. So if someone is resigning a company, they'll kill that VM and create a new VM using tools like VMware and VirtualBox. You can try Oracle VirtualBox. You can download, it's free, it's open source. If you download, it gives you an option to how much RAM you want, how much ROM you need to set. It will split that RAM, that ROM, and gives you an option to choose Linux, Ubuntu, or Fedora, or any other Linux variant. And you can use Ubuntu version in your Windows version. Okay, that is what typical virtual boxes, VMware virtualization software does. Now with virtualization, industries manage to solve hardware scaling. They now can vertically scale by having as many machines as possible, so that the individual developers can work on, implement, use version control tools, push the code to remote repository, and then publish a build and deploy it on production. Okay, that's how that people were managing. Now this also arised into another problem. Okay, what was the problem? When someone is building a project in one particular virtual machine, it has become difficult. Let's assume developer 2 is using this, developer 1 is using this. Okay. Now developer 1 is working on front end, on developer 2 is also working on front end. Both are working on one code change in React or any JS framework. Person 2 figured out that there is an issue that needs to be fixed and he can reproduce it in his virtual machine. But person 1 is unable to reproduce that problem. Everything runs fine to him. Person 1 tells the developer 2, hey, my code is ready to go to build and I'm good to deploy. But person 2 doesn't agree because he uses the same code, he could find a new issue and he has a fix also. And this guy has created a build with the fix and his deployment is also ready. Now, for the guy who is doing the deployment, he's puzzled. Should I rely on this or should I rely on this? Which is right build for me to merge into main repository and deploy has become a primary question. Okay. So, to avoid these problems where virtual machines manage to create a snapshot of a hardware to individual developers, but they are unable to share the instance of the code because they are not able to reproduce in that unique virtual machine. Okay, it's only reproducible in particular virtual machine, but not in the other virtual machine. It is very difficult for a DevOps guy to go figure out where is the problem. It's actually not his job, but to decide which branch to merge. Should I merge one or branch two to prod? It becomes difficult for the DevOps engineer to figure out. Okay, to avoid this problem, containers were introduced. Okay, so if you look at containers in general, there are container tools which are open source called Podman. Container I used in the past was Containered, okay, which is not that cool. Hyper-V is also one container which is nothing but an add-on to the hyper version virtualization software. Okay, and you might be hearing which is famous, which is called Docker. Okay, I'll tell why Docker became famous, why people use Podman only, why people there's another tool called Rancher Desktop. Docker copied from Rancher Desktop. Okay, this is one. So these are container softwares. Okay. Now what does containers do? How different they are when compared with conventional virtualization software. Okay. Now if you look at virtualization softwares, you have an operating system, you have a kernel, you have an hardware. So hardware has operating system has kernel, kernel has input output devices, system utility programs. On top of this, you have an app. Okay. What virtualization does? Virtualization will actually create copies of this. So it will create hardware, 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 OS, 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 kernel, 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 utility program, and app. Okay. So your app layer, you will get three utility layers, you'll get three kernels, you'll get three operating system, and you get virtually three machines. You from one machine, you created three machines. Okay. What containers do is they will not touch the operating system, the hardware. They will touch only the some programs in the utility. Okay. They'll also not touch kernel at a very large level. They'll only touch the system utility program and the application layer, and they create copies of these. Okay, we'll try to understand how this works. So imagine there's a company called Sai Corporation. There are 10 developers. So Sai bought one rack and created 10 VMs. Sai's developers complained, hey, I could reproduce a problem in VM1. I couldn't reproduce a problem in VM2. So the DevOps guy is not able to build the product. Okay. Now Sai bought Podman, which is a container software. What Podman does, instead creating VMs, Sai now trying to create container on top of a operating system instance. Now his rack has hardware, his rack has operating system, his rack has kernel. He's trying to use Podman to create copies of system utilities and apps. So at a very high level, if you observe, you will have a common hardware, you will have a common operating system, you will have a common kernel, but you will create copies of your utils or system software and your app. Your app. So you will get container 1, container 2, container 3, container 4, container 5, container 6. Okay. Now, what you see over here, this layer, there are 6 containers. These containers are typically called as images. Okay. Images is nothing but a snapshot of a utility module and an application layer. Now this snapshot with the combination of the utility module on the app layer can be used on any operating system and its kernel. Okay, so I can use container 1 on one operating system and another kernel, operating system 2 and its own kernel, another operating system and its own kernel. So I can use the C1 in 3 machines without any problem. Okay. So now what happened? Sai, who is running the company with virtualization software, he's creating containers so that, if developer 1 tells me, hey, I have an issue, I could reproduce the issue, I will give the container where I can see the issue. You open that container on your machine and figure out where the problem is. So you are now trying to share containers because they are utility programs, they are application programs. You are not sharing the operating system and kernel itself. So when you share container 1 from developer 1 to developer 2, the developer 2 should have a place to open that container, right? So that's why we have what we called image and daemon. Okay, let's, instead looking at Podman, let's look at Docker. Okay, so whatever we created as an image, let's call it as Docker image, and there is something called Docker daemon. Docker daemon is like a host. Okay, and all of these will sit in what we call Docker engine or container engine. Okay, or container engine. If you go back to the VMware, sorry, if you go back to the first slide, there is certain tech stack, right? there is certain tech stack here which was initially deployed on all the machines for all the developers to use. Now, in VMware, in virtualization, you created clones of that machine or copies and again deployed the hardware, deployed the tech stack. Now, in containers, the good part is because they are utility programs on a particular hardware which is not being shared, only this layer is shared, which is user mode. This is called kernel mode. Now you can decide what tech stack you need, what tech stack you don't need. Okay. So in container one, if there is an issue with a DB, and if the developer one figures out that there's an issue with the DB, he can create a container and share it with developer two, which only has DB. And he can look at the issue of the DB and fix it, and the container will now have the fixed code. So if you look at virtualization feature, you have a problem of sharing the instance. Now you don't have that instance sharing because you're not copying your hardware, you're not using the hardware, you're only using your application layer and the util layer. Okay, so this layer will eventually help you manage your software combination from one person to another person. Okay, now how that works? It works inside what we call container engine or a Docker engine. Okay, now all the container copies are, we call it as Docker image. Okay, Docker image contains, let's assume there's an issue with PostgreSDB. Okay, and there's a table. In that table, for one person he's telling that the data type is a number, the other person it is being shown as string. Now he creates his container image and share it with daemon, which is the host. Okay, typically in case of Docker it works through REST APIs. Okay, and daemon contains the host where it will eventually help share that container or image to the target person. Okay, how does it do? It does using something called Docker registry. Okay, what is registry? In NIT Tiruchinappalli, if you go to your canteen, there will be one register where if you go for lunch, you'll write your name, roll number, and do a sign, right? So the guy who is running the canteen will do the bookkeeping on who is coming today, what is his roll number, and did he eat the food or not. So he maintains a register to know who ate the food on 25 December, who ate the food on Jan 1st, last Sunday is the consumption high or low. He used this registry to manage those tasks. Similarly, in case of containers, especially with Docker registry, you created one image, you will push that image to Docker registry so that any other developer wants to get information, he can go to the registry and download that container. Okay, I'll give a very simple use case in case of a real world example. Imagine there is a new developer who joined and he wrote an HTML code to change a logo. But for this guy, the logo is not reflecting. There is a senior resource who is sitting in, let's assume, Lisbon, and this guy is in Hyderabad. This guy is asking for help. So the guy in Lisbon can't log into his machine and review it unless until they do a Gmeet or uh, WebEx, right? So what this person will do is he will install Docker desktop, and using Docker desktop software, he will create an image of his machine. That image only contains the .html problem and system utility projects. And he submits this image in Docker registry. And this fellow will tell his senior, hey, I have uploaded my image in Docker registry. go search the image with my name and download it. So the senior will also have Docker desktop. He will have access to Docker registry. He will search the name of the Docker image which this fellow has given, downloads that image, which is nothing but a container, looks at the issue, fixes the issue, pushes back that image to the registry and tells that, hey, I fixed it. Next day morning in Hyderabad, this fellow comes in, downloads that container which has recent changes, and then publishes the code to production. Okay. Now, if you compare this way of developer interaction versus the conventional approach, sharing machines, sharing instances through physical hardware is very difficult. Sharing instances, sharing machines through VMware is also very difficult, because you either need to give access to user 2 on this machine, make him admin, so that he can work and fix it. But if you are unable to give any security rights to a third party user to your machine, there's no point in fixing it through shared development. Okay. Now Docker images helps you do that without compromising other features of your operating system or your software. It can only give the image of whatever files you want to share to the registry, and you will eventually share it to the target user. Okay. All these image creation, image movement to registry, registry to pushing to the target fixes it and then pulls into image. All this action is taken care by Docker engine, and especially Docker daemon. Okay. Got it? So any questions so far?
No, sir.
Okay. Now let's look at what does images contain. As you remember, we are not sharing hardware, we are not sharing OS, we are not sharing kernel. We will only share system util and app layer. Okay, this layer is typically shared. All the containers were typically built for Linux variant machines. Okay, initially they are built for Linux variant machines. If you look at Linux, there are so many Linux versions. You have Ubuntu, you have Fedora, you have Plumo, I guess, Plume. And there is one thing I know is any other Linux operating systems you guys know apart from Ubuntu, Fedora, Plume? No one knows any other OS
Sir,
apart
Kali,
from, huh?
Kali,
Spelling?
Kali,
KLI, Kali. Acha. Is it a Unix variant?
Linux.
Is it a Linux variant?
Yes, sir. Sir, we say Kali Linux.
Acha, acha. I'm not aware of this. Okay, cool. Yeah, see 1, 2, 3, 4. When Linux was first developed, they have open sourced the operating system and kernel. So when they open sourced it, if you remember from your undergrad operating system course, there's a textbook called Peter Galvin. You might have seen preemptive scheduling, non-preemptive scheduling, contagious memory allocation, non-contagious memory allocations. These are techniques for process management and memory management. Okay. Different developers thought there are better ways to do process management and better ways to do memory management, and created their own versions of operating systems. Okay. So if you look at Ubuntu, Fedora, Plume, Kali, all these have underlying same Unix OS architecture, only some additional logic for memory allocation, process management are different. Okay. So on the whole, their system utility programs are also almost same. Okay, because they are same, tools like Podman, tools like Docker manage to create clones of utility layer and app layer rather than creating the clones of kernel, OS, and hardware like how VMs have done. Okay, so what Podman and Docker has figured out is, hey, all the Unix variants have same OS and underlying kernel, only the logic for process and memory management varies. So their ability to manage the system layer, which is the utility layer, and the app layer will always be same, right? So whatever this Docker daemon is, this Docker daemon takes care of executing utility programs from the respective image on any Linux variant. So for example, I picked up an image from an operating system called Ubuntu. Okay, I have a Python code, I have a Python installed, that's my app, and there's a utility program. So there will be one utility library for Python to Ubuntu OS. Now when I create an image, what Docker daemon does is, when someone is trying to open this image in Fedora, okay, Fedora, so I have the same system utility file, I have the same Python code and app, but Docker daemon will try to create a mapper between Ubuntu system utility, Fedora system utility, and ensures that the app runs on the Fedora as well. Okay, this may not work in OSs like Windows, Debian, okay, Solaris, primarily because their utility layer, their kernel layer are totally different. Okay, so in early days, Podman, Docker, Hyper-V, Container, whatever container tools were developed, they were primarily developed for Linux variants. Okay, but in today, in these days, whatever daemon we have, it is now expandable. They have now come up with a better mapper, so that you can now write you can do system utility communication between a Linux variant and a Windows variant, Linux variant to a Debian OS variant, Linux system utility variant to Solaris. Okay, because they started offering plugins to the mapper function. Okay, so this is how the underlying images which you create are mapped to the target operating system and ensure that they work on their hardware. If you carefully observe, we are not sharing hardware. We are only sharing the system utility layer and the app to the target users. Okay. So far what we have seen Docker image, which is nothing but a system utility layer and the app layer, and you have Docker daemon, which is typical engine to do the mapping from one OS to another OS so that the image can be opened. We have seen Docker registry, which is nothing but a repository of all the images which are created for people to consume. There is something called Docker Hub, okay, which is uniquely introduced by Docker company. Docker Hub gives you predefined templates of images which come with special software. So for example, again, go to Sai Enterprises. Okay, Sai wants to test one code in Python 2.7, Python 3.0, Python 3.1, and Python 3.2. Now if he has to go back and do the study like 10 years ago, he have to buy 1 2 3 4 machines, where he has to install Python 2.7, 3.0, 3.1, 3.2 and run the code. This is one approach. The second approach is create a VM. Don't buy machines. You have virtual machines. Okay. So that it has 2.7, 3.0, 3.1, 3.2 and you run the code and check whether it is working or not. But in case of Docker, a container approach, you don't need virtual machines also. All you need is you use same machine, one machine, and you have multiple containers which has system utility and app with Python 2.7, app with Python 3.0, system utility app with Python 3.1, system utility app with Python 3.2. So that the Docker daemon sits here and it writes mapper to your own operating system. So that when you run this code in the Docker desktop, that code will run. So if you look at the historical way of doing it versus today, there's a additional hardware, time intensive, costly approach. In virtualization, it is costly. It's not timely approach. You can do it quickly. But in case of current approach, your hardware cost, time consumption is pretty low because you're creating multiple images at the same time. Now the question is for Sai, how can he install 2.7, 3.0, 3.1, 3.2? He has to physically go to Python website, get the 2.7 build, download it, and do the install, right? Because it takes more time for him to do all these things. Instead, spending that time, what Docker Hub gives you is it gives you predefined template. So templates like you can get images where it has Python 2.7. You get images which has Python 3.0. All you have to do is pull this image into Docker desktop and start running the code. So you don't need to do the software management. You don't need to download and install that software, set environment variables, configure space. All those things are taken care by Docker Hub. Okay. So how people in industry use Docker? Why they use today? Hello. Sorry. Is there a question?
Oh, sir.
Okay. I think we have to close by 9:20, right?
Sir,
Yes. No.
9:30.
Huh?
9:30, sir.
Okay. Cool. Cool. Thank you. So let's look at how people in current companies use this Docker for their development. I think you guys can be on mute. Maybe. Yeah. Yeah. Now, if you look at how these companies will use it in practice. So when you join a new company after your master's program, a DevOps engineer will give you, an IT team will give you one machine. They'll give you one laptop. They'll install Docker desktop. Okay. They'll give connection to Docker Hub. Okay. Now, when you, in your first week in your training, they will tell you that our product uses React JS, our product uses Vue.js, Express for integration, Node.js, then MySQL DB, MongoDB, and then it uses some REST. Okay, let's assume this is a tech stack. While you are in training, what they will do is they will ask you to go to Docker Hub and there will be a template called starter developer template. In that template, they will have all these technologies installed in right versions. All you have to do is also IntelliJ. Let's assume you need IntelliJ or Vim. Okay. They'll give you this template. All this guy who is new joined in the new company has to open this template and pull the code from the given repository and start working on the development. Imagine after 3 days, he screwed the code and the entire code is not working. He has an option to go back to Docker desktop, kill the template, go to Docker Hub, get a new starter development boilerplate or what we call the scratch template. People call it scratch template or ground zero template, which has everything from scratch, and start the development again. So this gives an advantage to the new developer to use as many templates as possible whenever he's gone wrong. And he can live with the template where whatever development he has done today, if he wants to reuse it tomorrow, he can push it to the Docker Hub, save that template. After 6 months, if he wants to redevelop it, get that template back and work on it. It is like a temporary copy of your development instance, which you will manage across all the team members and eventually use it. Okay, this is one way they'll use for new developers. Okay, how QA team uses Docker desktop or Docker in general, containers in general. Okay, so imagine you have a web layer, you have a middleware, and you have a database. Okay, QA team helps testing for security, helps testing for vulnerability, helps testing for injection, SQL injection, especially in DBs. Okay. Now imagine your product works very well on PostgreSQL SQL 2.9, let's assume. Okay. And you were asked to release on top of it. After 6 months, PostgreSQL told Sai Corporation, hey, we are not no longer supporting 2.9. Please upgrade to 3.1. Okay. So what the QA guy does is in Sai Corporation, he will create one image which has PostgreSQL 2.9. He will create one image which has PostgreSQL 3.1. He do all the testing, signs off. He also does the testing if the test cases fail. Okay, if the test cases fail because of the version change, because of something addition happened in PostgreSQL, he can directly give this image to the developer to figure out the errors in the logs and fix it. In the old days, at least not before containers, it is very difficult to share a VM, it's very difficult to share a physical machine to manage such type of issues. So all vulnerability problems, security problems, all the companies today will create as many Docker images as possible so that they can eventually manage their development activities and end user activities. Now, what is it for a DevOps engineer in all this game? Okay, what this fellow will do? This guy becomes the responsible for maintaining Docker registry. He is the owner for Docker registry. He manages Docker images. He manages Docker Hub. He creates boilerplates, empty templates, senior developer templates, templates for stage platforms, templates for prod. So someone is trying to deploy something. Oh, let's do that. Wait. So someone is trying to deploy. So today they deployed version 2.1, some code in production. Okay. Now what DevOps engineer will do when version v2.2 is released, he'll create a Docker template for stage. They will deploy this version. If the testing is passed, then he'll create a prod template which contains v2.1 and they deploy this and the QA tests it and they release. So the DevOps engineer will become responsible for creating templates for various product versions with various tech stack combination so that the QA and the development team can do the product delivery on time. Okay, this is what the DevOps engineer will eventually do. So virtualization, container management is something the key aspects of a DevOps resource as of today. In the Git book, I have I have given detailed steps on how to create Docker image, how to set up Docker desktop, how to manage registry. Okay. So in your second assignment, what we'll do a team activity. Okay. All of you, I think I spoke to Ashish. You guys can form teams. I'll give you some tasks to perform in your assignment. Like you can use your own machine, your local machine. You can install Docker desktop. Okay. And create container for, you create one container template where you have Python 3.1. Create one container called PostGRE 2.9. Create another container PostGRE 3.0. Okay. So I want you to try out Docker desktop. I'll give you a series of commands you need to follow. Create as many templates as possible. Pick one Python program, some random Python program or some random bash program, and run it in 2.9 image, 3.10 image, and share the screenshots. Okay. So, or you can share me the Docker image also. I will open the image and check if everything is made sense, right? So this will be your typical assignment too, where I'll give detailed steps on how to run your Docker image, manage your Docker template, and you can work as a team and try to be productive. Okay, great. Any questions so far?
No, sir.
Okay. So Ashish is 14th holiday.
Yes, sir.
Okay, okay. So I'll take a class tomorrow on Thursday. Is there a check if there is a possibility to take another class this week? Okay, apart from Friday.
Okay, sir.
Great. Thanks everybody. Have a great day. If you have any questions, please write to me.
Sir,
Hmm.
I think you forgot to extend the date of assignment.
Hey, I did. 1 second. Let me check.
Sir, it is 27 February only.
Okay. I'm sorry. Let me do that now. 1 second.
No, sir, it's okay.
Okay. I'll extend it and I'll update Ashish. Okay.
Okay, sir. And sir,
That
we
is
had
assignment.
used Firestore database in our project.
That's fine. That's fine. It's okay.
Okay,
It's
sir.
fine. I have no
Thank you, sir.
problem. Yeah. Thanks everybody. Bye.